For the last decade, if you asked almost anyone in the space industry one simple question, who changed spaceflight forever? Most people would give you the same answer: SpaceX. Not because it built the biggest rockets, not because it launched the most satellites, but because it solved a problem that had frustrated engineers for more than half a century. Every time a rocket launched, billions of dollars disappeared. Imagine buying a brand new Boeing 747, flying it from New York to London, and then throwing the entire airplane into the ocean after just one flight. It sounds ridiculous. Yet that's exactly how rockets worked for decades. They were some of the most advanced machines ever built, designed to survive incredible forces, only to be destroyed after completing a single mission. That wasn't just expensive. It was one of the biggest reasons space remained so difficult to access. Then SpaceX proved something that many experts once believed was nearly impossible. A rocket could fly to space, return to Earth, and land safely, ready to fly again. It was one of the biggest engineering breakthroughs of the modern space age. Suddenly, reusable rockets weren't science fiction anymore. They were reality. And something interesting happened next. Countries around the world started chasing the same dream, because whoever mastered reusable rockets would dramatically reduce the cost of reaching space. The obvious solution seemed simple: copy SpaceX. After all, why reinvent something that already works? Why spend years developing a different system when the world's most successful reusable rocket was already showing everyone the blueprint? That's exactly what many people expected China to do. Build a reusable rocket, add landing legs, land it the same way, mission accomplished. But that's not what happened. Instead, Chinese engineers made a decision that surprised many people following the space industry. They didn't reject reusable rockets. They rejected the assumption that there was only one way to land them. And that single decision may have changed this story completely. So, if landing a rocket sounds simple, that's because we've only ever seen the final few seconds, the dramatic moment, the engines firing, the rocket slowing down, the perfect landing. But what you don't see is everything that happens before that moment. Imagine trying to balance a pencil on the palm of your hand. Now imagine doing it during a hurricane. Now imagine that pencil is over 40 meters tall, weighs hundreds of tons, is running on explosive rocket fuel, and is falling back toward Earth faster than the speed of sound. That's the challenge engineers are trying to solve. Landing a reusable rocket isn't just difficult. It's one of the most demanding engineering problems ever attempted. Every second, the rocket must know exactly where it is, how fast it's moving, how much fuel is left, how strong the wind is, how much thrust each engine is producing. A tiny mistake, just a fraction of a second, could mean the difference between a perfect landing and losing the entire rocket. That's why, for decades, most space agencies didn't even try. The risk was simply too high. Then SpaceX changed everything. Its rockets perform what's known as a powered vertical landing. As the booster falls back toward Earth, its engines reignite. The onboard guidance system continuously adjusts the rocket's position, making thousands of tiny corrections every second until it touches down. Watching it looks effortless. Building it was anything but. Years of failed landings, explosions, software improvements, and engineering breakthroughs led to those famous Falcon 9 landings we see today. After seeing that success, most people naturally assumed every future reusable rocket would work the same way. Because when one solution becomes successful, the rest of the world usually follows. History is full of examples. One company invents something revolutionary, everyone else copies it. That's how technology often evolves. Which is exactly why China's next move surprised so many engineers. Because instead of asking, how do we copy Falcon 9? Chinese engineers asked a completely different question. What if the rocket doesn't have to land the same way at all? At first, that sounds like a small difference. It isn't. Because changing the way a rocket returns changes almost everything. The software, the hardware, the recovery system, the launch platform, even the economics behind every future mission. And that's where this story takes an unexpected turn. Because China wasn't just designing another reusable rocket. It was rethinking the entire recovery process from the ground up. Up until now, we've been talking about the problem. Now, let's talk about China's answer. When most people imagine a reusable rocket, they picture exactly what SpaceX made famous. Of boost returning to Earth, extending its landing legs, and touching down either on solid ground or on a drone ship floating in the ocean. It's an incredible solution. But it's not the only possible solution. Chinese engineers looked at the same problem. and started asking a different question. What if the rocket doesn't need to support itself after landing? That single question changed everything. Instead of focusing only on making the rocket land, they began exploring ways to let the recovery system help catch it. Think of it like this. Imagine you're trying to park a bicycle. One option, you balance it perfectly on its kickstand. Another option, someone reaches out and holds it for you. Both methods work, but they're solving the problem in completely different ways. That's the philosophy behind China's recovery concept. Rather than relying entirely on deployable landing legs, one of China's recent reusable rocket demonstrations explored a recovery ship equipped with a capture system designed to secure the returning booster after touchdown. At first, that might not sound revolutionary, but removing or reducing the need for large landing legs could create engineering advantages. Landing legs add weight. They occupy valuable space. They must survive launch, the harsh conditions of space, and the violent return through Earth's atmosphere. Every extra kilogram carried into space is one less kilogram available for satellites, scientific equipment, or cargo. In rocketry, weight is everything. Saving even a small amount of mass can have a surprisingly large impact on performance and cost. That's why engineers spend years trying to eliminate even tiny amounts of unnecessary weight. So instead of asking, how do we build better landing legs? China appears to have asked, what if we don't need them in the same way? That's a completely different engineering mindset. But here's where it gets even more interesting. This doesn't necessarily mean China's approach is better than SpaceX's. And it doesn't mean SpaceX's approach is worse. They're solving the same problem. From two different directions, SpaceX optimized the rocket. China is also exploring ways to optimize the recovery system itself. It's similar to two people trying to cross a river. One builds a faster boat, the other builds a stronger bridge. Different solutions, same destination. And throughout history, that's often how the biggest technological breakthroughs happen. Not by copying the first successful idea, but by challenging the assumption that it was the only idea. Which brings us to the biggest question of all. If multiple countries are now developing completely different ways to reuse rockets, what happens when those ideas start competing with each other? Because in engineering, competition doesn't just create winners, it accelerates innovation. And in the race to make space cheaper, faster, and more accessible, that may be the most important development of all. So, did China actually change the future of reusable rockets? The honest answer is, we don't know yet. And that's exactly what makes this moment so fascinating. Because every major breakthrough in history looked like an experiment before it looked like a revolution. The Wright brothers flew for just a few seconds. Today, millions of people fly every single day. The first reusable Falcon 9 landing was treated by many as an incredible engineering demonstration. Today, rocket landings have become almost routine. Every revolutionary technology begins the same way. One successful test, then another, until one day, people forget there was ever another way. China's reusable rocket program is still in that early stage. There are still engineering challenges to overcome, many more tests to complete, many more flights to prove long-term reliability. That's completely normal. Space engineering isn't measured in weeks, it's measured in years. But here's why the rest of the world is paying attention. Because China isn't just trying to launch rockets, it's trying to make space cheaper. Think about what happens if launch costs continue to fall. More satellites, better global internet, cheaper Earth observation, more scientific missions, larger space stations, regular moon missions, and eventually, human missions much farther into space. Every dollar saved on launching a rocket can be invested somewhere else. More science, more exploration, more innovation. That's why reusable rockets matter so much. They aren't the destination. They're the key that unlocks everything that comes after. And that's why this story was never really about China, or even SpaceX. It was about what happens when one breakthrough inspires another. One company proves something is possible. Another company asks, what if there's an even better way? That's how technology moves forward. Not through imitation alone, but through competition. Because real innovation doesn't happen when everyone builds the same thing. It happens when someone has the courage to challenge the blueprint everyone else accepted. Whether China's recovery system becomes the new standard, or whether it simply pushes every other space company to build something even better, the outcome is the same. The entire space industry moves forward, and that's good news for all of us. Because the faster we reduce the cost of reaching space, the faster humanity can build the future we've imagined for generations. If you love discovering the technology stories hidden behind the headlines, then you're exactly where you need to be. Subscribe to Byte Dynasty, because the next engineering breakthrough that changes the world probably won't look revolutionary on day one, but years later, we may all look back and realize that was the moment everything changed.